Hey, mathletes, here we are looking at logarithm graphs and inverses. So really, we want to tie this idea of logarithm graphs of just being inverses of our exponential graphs. So what we'll notice is that there always be a reflection across that y equals x line, and that will really help when we're graphing our logarithmic graphs. Okay, so recall that the connection between exponents and logarithms, that if we rewrite this exponent as a logarithm, our base becomes our base of our logarithm. Okay, our exponent is the solution of our logarithm, and the result is our y. Okay, so notice if we're changing and when we're finding inverses, we interchange our x and y's. So if we flip-flop our x and y's, we have log of b x equals y, which is going to be our parent function of our logarithm graph. So it's a direct inverse of our exponential graphs. Okay, so recall when we were finding our inverses. Okay, so if I wanted to find the inverse of y equals x squared plus 3, the first thing I do is I interchange my x and y, so I get x is equal to y squared plus 3. Now I'm going to solve for y, meaning I'm going to isolate and get y by itself. So I'm first going to subtract 3 from both sides, so I get x minus 3 equals y squared. Now to undo the squared, well, that is done by taking the square root of both sides and remembering the plus or minus. So our result is we get our inverse is equal to plus or minus the square root of x minus 3. Okay, so we get this graph where square root of x minus 3 is there. Then if we're thinking about the minus part of that, that's that graph there. Okay, notice that this is a reflection across the y equals x line of our original function, x squared plus 3, which is a parabola with a vertical shift up 3. So that vertical shift changed to a horizontal shift for our inverse. Okay, so as we think about our logarithm functions, we want to think of them as a inverse of our exponential function. Okay, so what we want to do is we want to find the inverse function, graph the inverse functions, switch the x and y's to graph the log. Okay, so in this example, we want to graph y equals log 10 to the x. Okay, so if we write that in exponential form, okay, I'm going to write it as 10 to the y is equal to x. As I switch the x and y's, I have 10 to the x equals y. Okay, so now I'm going to graph the inverse. Well, when I graph exponential functions, it's easiest to just think of the three kind of core anchor points when x is -1, when it's 0, and when it's 1. So I'm just kind of making a table here. Okay. So when x is -1, our y, 10 to the -1, is going to be 1 over 10. Because when something is raised to a negative power, it's the reciprocal. Okay, anything to the 0 power, so 10 to the 0 is 1, and 10 to the first power is 10. So as I graph those points, at -1, I'm at 1/10. At 0, I'm at 1. And at 1, I'm at 10. So my inverses are going to be such that I interchange these, and now think of this as my x and these as my y's. So my first point is 1/10, -1. I'm right here. Okay. At x being 1, I'm at 0. Okay. And when x is 10, my y is 1. So I get this graph. Okay. Notice for exponential graphs, we have asymptotes we've talked about before. Our asymptote here is at our axis, our x-axis. But as we think about logarithms and they're a reflection over our y equals x line, our new asymptote ends up being now our y-axis. So this blue graph is going to get infinitely close to that y-axis, but it's never going to touch or cross that. Okay. So again, looking at our example, how would we graph log 2 to the x? So first I'm going to graph y equals 2 to the x, which is the inverse of log of 2 to the x. When I graph those, okay, again, I'm going to use my anchor points of -1, 0, and 1. So my y values for my inverse, okay, is going to be, well, -1 is 1/2, 1, and 2. So as I graph that at -1, I'm here, and at 0, I'm 1, and at 1, I'm 2. And I could anticipate, well, at 2, I'm going to be 4. Okay. And I'm going to get my exponential graph with its horizontal asymptote there. Okay. Now, I'm going to draw my y equals x line. I'm a little bit off there. There we go. Okay. And now I'm going to choose the points that I have here and interchange them. And now these are my y values, and these are my x's for my logarithmic graph. Okay. So I'm going to have the point at 1/2, I'm -1. At 1, I'm at 0. At 2, I'm 1. And at 4, I'm at 2. And again, this is my logarithm, log base 2 to the x graph, where I have a vertical asymptote there at the y-axis. Okay, so it gets closer and closer as we get approached here. And it's going to be a growth graph here. Okay, so as we generalize these ideas of logarithm functions and their graphs, okay, we're talking about the graphs in the red, okay, but we're always going to try and relate it to our inverse graph of the exponent. So recall, if we're talking about this inverse graph g to the x, where b is our base, okay, when b is greater than 1, we had a growth graph. So as we think of that with a inverse, our log graphs are also going to be a growth graph, and our asymptote is going to be vertical. Okay. Well, as that changes, as that b value is between 0 and 1, okay, we get a exponential decline graph, a decay graph, okay, for our inverse. So when we reflect that over our graph, we still get a decay graph, but our log function looks like this. Okay, where now we get a graph that approaches its asymptote, but it's going to approach it from the top. So it's going to rise up as it gets closer to that asymptote, and it's going to decay down. So this happens when our log graphs, and that b value is between 0 and 1. Another idea here is looking at graphing this log of 3 to the x. So again, I'm going to think about my inverse. Okay, so my inverse I'm going to call g to the x. Okay, so remember that my inverse is going to be 3 to the x. So here I have made my table already. So there's my anchor points. Okay, you can always do more if you want. Okay, so as I get these points, at -2 I'm 1/9. At -1 I'm 1/3. Approximate 0, 1, 1, 3, and 2, 9. We're up here. So then we have this our graph, we're not going to cross our asymptote there. Okay, so that's my inverse g of x. So now as I want to graph my f of x, I'm going to interchange these values. So now this is representing f of x, and this is representing our x. So when x is 1/9, we have a value of -2. When x is 1/3, we have a value of -1. At 1, we are 0. At 3, we are 1. And at 9, we are 2. So again, we see our logarithm graph behaves like that. Okay. As we're talking about logarithm graphs, we also want to talk about the natural logarithm. So our natural logarithm is written as ln. Okay. So all the ln it needs to be interpreted is that ln is equivalent to log base e. So on our calculators, and it's used so often that it just gets its own ln. So it's a unique type of log. It's a natural log function. Okay. So as we think about graphing our natural log function, we think about graphing y equals e to the x. Okay. So as you graph that, you're going to see, if we think about our anchor points there and our e to the x value, well, e to the -1 is going to be 0.368. Anything to the 0 power is 1. Anything to the first power is itself. And recall that e is the irrational number approximated at 2.718. So when we have these graphs, this graph, we have these 3 anchor points. Okay. And then as we graph our inverse function, or the natural log, okay, we're going to see it's the reflection of that graph. Okay, so a clear example here for you. So graphing f of x equals our natural log of x. Well, I'm going to think of the inverse first. So the inverse is g of x, which is e to the x. So again, we get 0.368. Anything to the 0 power is 1. Anything to the first power is itself. And e squared is 7.38. Okay, so as I graph those, -1, about 1/3. At 0, I'm 1. At 1, I'm 2.718. And at 2, I'm 7.3. So there's my e to the x graph. And I'm going to use that and think of that as a reflection across this y equals x line. And I'm going to now be able to graph my natural log by just interchanging these points. So now this is f of x, and this is x. So when x is 0.368, f of x is -1. When x is 1, y is 0. When x is 2.718, y is 1. And that's 7.38, y is 2. So then we get our natural log graph there. That concludes our notes today. Please highlight any questions you have and bring them to office hours.